All right, we're ready for section 1.3, and we're going to be reviewing. This is an Algebra 2 concept, but reviewing complex numbers, the number I, and then we'll be looking at, in the latter part of the lesson, quadratic equations that have solutions in the complex number system. So first of all, let's just do a quick refresher of the number I, because the number I, of course, is part of a complex number. So the number I, remember, is equal to the square root of -1. I in algebra or in any math class is not a variable because it cannot just represent any number. It always represents the same expression. It always equals the square root of -1. And from that, we can derive another helpful truth, another helpful equation. If we just raise both sides of this, if you want to call it a definition, to the second power, we get something else that's true, that's useful. I squared is equal to just regular -1. So I itself is equal to the square root of -1. And then if you want I squared, as you can see mathematically, we arrived at equaling to -1. Okay, so with that said, we're going to do some operations with complex numbers. A complex number is part real and part imaginary. Okay, so this is an example of the format of a complex number. The A represents the real number part, and then you will have either plus or minus the imaginary part. And it is important that they're written in this order. So anytime you're writing a complex number, notice they're always written with real number first, followed by plus or minus the imaginary. Same thing here, real, and then plus or minus the imaginary. So when we're doing operations with complex numbers, pretty simple really. We just add like terms or combine like terms. So the real number terms get added together, 2 and 6, and then the imaginary numbers will get added together, combined. So -3i plus 8i is plus 5i. And that's it. When it comes to adding two complex numbers, it's pretty simple. You just combine like terms. Subtraction can be tricky. You got to be careful because we'll do this without parentheses. When you're subtracting that second complex number, what I would do, I always recommend that you distribute -1 to remove the parentheses around that number. And that way, that will help you avoid a common mistake that people make when it comes to subtraction. Most people will subtract the 4 because they see it, but they won't subtract -4, which is really another way of saying addition. So now that we've removed the parentheses by distributing the -1, we can go back and do what we did up here. We can just combine the like terms. The real number terms are like, so -3 minus 4 is -7. And then the imaginary, these are called pure imaginary numbers, 2i plus 4i would be 6i. And there's our answer for that example. All right. All right, moving on to our next example. Now we're getting into multiplication. And I teach the FOIL method when we multiply binomials together. And that's exactly how we're going to do complex numbers being multiplied together. We're just going to pull out FOIL. First, outside, inside, last. So multiplying the first two terms together, 3 times 2 is 6. The outside terms, 3 times I is 3i, positive. The inside terms, that would be -4i times 2, which is -8i. And then the last terms together, this is where you have to be careful. This is where I see mistakes being made. When you multiply the last two terms together, -4i times 1i, that would be -4i squared. Okay, but remember at the beginning of this lesson, we identified I squared as equaling -1. So anytime you have I squared pop up in a problem, you need to replace it. You never want to leave I squared as part of your answer. You can simplify by replacing I squared with -1. All right, so let me go ahead and combine these two i's. 3 minus 8 is -5i. And just so I'll illustrate it here, what this becomes is -4 times -1. So always replace I squared with -1. And now we'll just finish this off. The real numbers become 6, and this is going to be +4. Negative times negative is positive. So 6 plus 4 is 10. And then the real number comes first, and then that is followed by the imaginary number, in this case, -5i. Okay, so 23 is a problem where the end goal is to remove the complex number from the denominator. So the rule of thumb in math problems is you never want a complex number in the denominator. And so the way we simplify this, the way we remove the complex number, is by using something known as the complex conjugate. So conjugate really is just a big word that means change the sign that's in the middle. Okay, so this complex number says 3 minus 4i. To get the conjugate, I'm just going to write 3 plus 4i. So it's just the middle sign of the complex number. It gets changed if you want the conjugate. And we're going to multiply by that on both the top and the bottom of this fraction. All right, and so on the top, this is the distributive property. 10 is going to multiply times both 3, so 10 times 3, and then 10 times 4i. And then on the bottom, you could use FOIL, but if you remember this, it'll save you a few seconds anyway. Whenever you multiply conjugates, this should always happen. Whenever conjugates are multiplied together, the outside product and the inside product, when you do FOIL, are just going to wipe each other out. So really all you have to do is multiply the first two together. 3 times 3 is 9. And then go to the last two. And again, got to be careful here because it starts off as -16 I squared. But remember, I squared always gets replaced with -1. So if I replace I squared with -1, this becomes -16 times -1, which is +16. And 9 plus 16 is 25. So this is a good visual for you to see how using the conjugate turned a complex number into just a regular whole number. And the way we write fractions that are complex numbers is we just break them up into two separate parts. So the real number part would be 30 over 25. And then the imaginary fraction part would be 40i over 25. And then if reducing is possible, you always want to do that. So I can divide by 5 to make this become 6/5. And this, again, divided by 5 would be 8i over 5. And that ends up being my final simplified answer. So the big takeaway here is to get rid of a complex number in the denominator, use the conjugate. Just change the middle sign. Number 25 is just the pure imaginary number. So whenever I does not have adding or subtracting included with it, it's just called a pure imaginary number. And they're a little bit easier to simplify. You just use the number I. So if this had been, for example, 3i, I still would be multiplying by I. 3i is pure imaginary because it doesn't include any adding or subtracting. So I'll just multiply by I on the top and the bottom, distributive property, so 2 times I, and then I times I, and we'll come back and clean this up in just a second. And then on the bottom, I times I. So again, just a reminder, anytime I squared appears, it needs to be replaced. So this needs to become -1, so does this. And then I need to put this in the correct order because the real number part of a complex number should go first. There's -1 plus 2i, and then the denominator would be -1. So a better way of showing this would just be +1, -1 divided by -1, and then minus 2i. And there's our simplified answer. So we did adding, subtracting, multiplying, and dividing with complex numbers and how we simplify those. And hopefully that makes sense. You'll get some practice opportunities with them. All right, so in problems like this, we're simplifying this complex number that is being raised to the second power. So I'm going to give you a choice. You can do what it says and literally just write down 1/2. And by the way, this is just a preference thing. What your book does here is not wrong, but I like to put I in front of the radical. Again, either way is fine. It's just a preference. So you could do this. It says to square it, which means multiply by itself, and then we could go through FOIL. So first would be 1/4. Multiplying the outside together, 1/2 times I root 3 over 2 would be I root 3 over 4. And then we get the same thing when we do the inside. Then when we do the last, I times I is I squared. Root 3 times root 3 was root 9, but it becomes 3 when we simplify. And then 2 times 2 is 4. Okay, so let's clean this up. Let's just go ahead and change, well, let me see. I'll go ahead and combine these two in the middle. So this is really just think about 1 plus 1 is 2I root 3 over 4. All right, so that takes care of those. And then this is going to become, remember I squared is -1, so -1 times 3 is -3/4. And now we combine these two fourths, these fractions, 1/4 minus 3/4 is -2/4. And the only thing left to do really is to reduce, because we can turn this into -1/2. And this again would also be 1/2, so I root 3 over 2. Now I said I'll give you an option. You can either do FOIL or we've looked at in Algebra 2 a 3-step mental math process. I won't walk through it, but you would get the same result. So the 3 steps would be to square the first term. So 1/2 squared would be 1/4. All right, that's where this came from. Then the second part of this would be, I'll call it first times second doubled. What's that mean? Multiply these together. This is what I mean by the first, and this is the second. Multiply those together, and then times 2. That's how we got this in the FOIL process. If you notice, these two multiplied together and then doubled gave us this. And then the third step is really just like the first. You just square the last term. So when you square square root of 3, you get 3 over 4, and then I squared, you square each one of these, so that makes it negative 3/4. So I'm not saying you have to do this, it's just to me it's a quick and easier way to come up with the squaring of a binomial without having to use the FOIL method. But if you don't like this, it's more mental math than you like, you're always welcome just to do the FOIL method. Do one or the other, and anytime you square a binomial. Okay, let's talk about how to simplify powers of I, various powers of I. And I've kind of started a little table here. Some of this we already know. I to the first, of course, is just I. Anytime you raise a base to exponent 1, it equals the base. We've already talked about how I squared is equal to negative 1. The way we get I cubed, if you think about it, it's just I times I squared. Because whenever bases are the same, you add the exponents together. So I times negative 1 is negative I. And then I to the fourth is just I squared times I squared. It's like negative 1 times negative 1, which is positive 1. But here's the easy way to simplify these powers of I. It's really focusing on this. Every time, if you notice, every time we have I that is raised to a multiple of 4 power, like 8, 12, 16, 20, 24, 28, it doesn't really matter. If I is raised to a multiple of 4 power, it always equals 1. So in other words, I to the 40th is equal to 1 because 40 is a multiple of 4. I to the 100th equal to 1. Anytime I is raised to a multiple of 4 power, then it equals 1. I to the 88th is equal to 1. So with that knowledge, we're going to use that I raised to a multiple of 4 power, and we're going to do a little factoring. So what I want here is the closest multiple of 4 to 23, and that would be 20. So multiplying I to the 20th times I to the 3rd gives me I to the 23rd. So if you think about it, in these problems, you really just have to know these. You just have to know what I squared, and I cubed is, because you're going to use a factor of I that will always equal 1 if you choose a multiple of 4. So I to the 20th, I to the 3rd, multiply those together, and you have your result, negative I. All right, so a little review of negative exponents. A negative exponent tells you to flip the base. So the reciprocal of I is 1 over I, and then you can change the exponent to positive. I'm going to use the multiple of 4 that's closest to 15, so that would be I to the 12th. And I would have to multiply by I to the 3rd to make it equal. All right. So I to the 12th is 1, and this is like our previous problem. I cubed is negative I. So I started off with 1 over negative I, but based on our previous slide, we don't want to leave the number I in the denominator of a fraction. So let's use the number I multiplied on the top and the bottom to remedy that. So 1 times I. So negative I times positive I is negative I squared. Well, I squared is negative 1, but the opposite of negative 1 is positive 1. So I wouldn't want to write an answer like this. Let's just say that the final answer is just I. All right, so let's simplify 6I to the 3rd. Well, I to the 3rd, as we said earlier, is just negative I. And then I to the 5th, if you use the factoring I to the 4th times I, I to the fifth is just 1, because that's what I to the fourth is. 1 times I is I. All right, so this becomes negative 6I, subtract 4I, and we end up with our answer of negative 10I. So big takeaway is how to factor these powers of I, how to factor so that we use a multiple of 4 exponent as one of the factors, and then whatever it takes to make the problem equal, the factor of 4 being subtracted, in this case, from the given exponent. That will be the other factor's exponent. All right, we're just about to the end. Let's take a look at this. So we're going to do the square root of this product. So we're back to doing FOIL. 3 times 4i, 3 times negative 3, 4i times 4i, 4i times negative 3. All right, let's see what we can do to simplify under the radical. Well, the 12i minus 12i is going to cancel, and I squared is negative 1. So with I squared being negative 1, this is going to become negative 9 minus 16. 16 times negative 1. So this becomes the square root of negative 25. And so when I'm doing the square root of a negative number, just think of this factoring. The square root of positive 25 times the square root of negative 1. And the square root of 25 is 5. And by definition, the square root of negative 1 is I. And so the square root of negative 25 is 5I. All right, and then we're going to solve some quadratic equations in this lesson. And factoring would be my preferred choice, but this is not possible in this problem. There are no factors of 8 that add up to 4. So I'm going to do completing the square, just a good way to review. So the blank represents the number that completes the square. So to get that number, you always divide by 2. Whatever's in front of x, divide by 2, and then square that result. So I'm going to be adding 4 to both sides. I've now made a perfect square trinomial, and they factor very nicely. There's the factored form of x squared plus 4x plus 4. And negative 8 plus 4 is negative 4. Now I'm going to do the square root property, which means the square root of both sides. And if you do the square root of both sides of an equation, remember we're looking for 2 answers. The degree of the polynomial will tell us how many solutions we should end up with. And if you forget plus minus, you're only going to come up with 1 solution, and you're supposed to have 2. So plus minus is very important. So the square root of negative 4 is 2i. So our final answers, it's really 2 complex numbers written in this condensed form. Negative 2 plus 2i and negative 2 minus 2i. But you don't have to break them apart. You can just leave them in a combined format like that, and you are good. Okay, I think that takes care of us. You're now ready to practice the assignment. So I hope this helps prepare you for that practice, but if not, if you need help, come and see me. I will see you next time.